Good morning, students. Today we are going to discuss about module number 1, that is basic concepts. Here we are going to discuss about steps to apply nodal analysis and problems on node analysis. Let us discuss about that steps to apply node analysis. So while we are going to discuss about that the steps how to apply node analysis, the first step is identify the principal nodes and choose one of them as a reference node for any given network, and it will treat as a reference node because the potential across the reference node or ground node should be equal to 0. The next step 2. The step 2 is label the node voltages with respect to ground from all the principal nodes except the reference node because at reference node the potential is equal to 0. Therefore, except that reference node in all the nodes in the given network, we have to label it as node 1, node 2, node 3 with respect to the ground. Next, step 3. Step 3 is writing that nodal equations at all the principal nodes except the reference node because reference node potential is 0. And nodal equation here it is obtained by applying Kirchhoff's current law first and then Ohm's law. The next, step 4. The step 4 here, that is the number of possible equations for a given network is number of nodes minus 1. Why number of nodes minus 1? Because the potential across the reference node is already we know that is it is 0. So by subtracting that 1 from the given n number of nodes for the given network. Therefore the number of possible equations for the given network is n minus 1 equations. Next, step 5. Step 5 is solve the nodal equations obtained in step 3 in order to get the node voltages. And step 6 is if any one voltage source lies between two nodes, we have to apply supernode analysis as to overcome the difficulty. So these are the various steps how to apply the nodal analysis and to find the solution for the given network. So let us go through that one simple network to analyze that nodal analysis with the following steps. So the given network shown in below figure consists of two voltage sources, namely as VA, VB, and having the resistors like R1, R2, R3, R4, R5. So for this network we are going to label that the number of nodes for the given network, that is 3, that is node 1, node 2 and node 3. So in these 3 nodes for the given network, how many number of possible equations we have to write means that is n minus 1, because already we know the potential across the reference node or node 3, it is connected to ground and it is equal to 0. So if you subtract that minus 1 from the given n number of nodes, then n minus 1 equations we have to write. So let us consider that node 1 initially. Node 1 is connected to various branches like R1, R2, R4. So consider that node 1 is connected to branch of R1, branch of R2, branch of R4. And we are imagine that there is a voltage V1 with respect to node 1 and to the reference node called node 3. So I am considering that a unknown voltage V1 is there at node 1 with respect to node 3. I want to find out that what is the amount of voltage which was there across node 1 with respect to node 3. To analyze this or to identify or to calculate this unknown node voltage like V1, I am applying the Kirchhoff's current law by analyzing the currents. While we are analyzing the currents, we have to imagine that the unknown node voltage have highest potential among that remaining all the nodes. Therefore, we are analyzing the currents all are going away from the node. So here in branch resistance of R1, I am analyzing the current of I1. In branch resistance of R2, I am analyzing that current of I2. In branch resistance of R4, I am analyzing the current of I4. So totally I1, I2, I4 are the branch currents which are moving away from this node 1, and the node 1 voltage is V1. And here I1 is the branch current which is flowing from V1 to VA, and I2 is the branch current which is flowing from V1 to V2, and I4 is the branch current which is flowing from node 1 to node 3 through R4. Now I am going to now I am going to apply the Kirchhoff's current law. The Kirchhoff's current law equation at node 1 can become as all currents are moving away from the node. Therefore, I1 plus I2 plus I4 is equal to 0. With respect to I1, by applying that Ohm's law here, I can write that I means we can write that V by R. But here I1 is the current which is flowing from V1 to VA. So I can write that in the place of I1 as V1 minus VA divided by R1. I can write that I2 as V1 minus V2 divided by R2. I can write that I4 as V1 minus 0 because node 3 potential is 0. So V1 minus V3, in the place of V3 I can write it as a 0. Therefore V1 minus 0 divided by R4 is equal to 0. Now I am going to simplify this equation. I can write that equation as V1 of 1 by R1 plus 1 by R2 plus 1 by R4 minus V2 divided by R2 is equal VA by R1. So take it as a equation number 1 for reference. Next, again I am going to apply Kirchhoff's current law at node 2. So if I am going to apply that nodal analysis at node 2, initially again I am going to apply that unknown node voltage V2 is there at node 2, and I am analyzing that currents or I am analyzing that branches which are connected to node 2, because in the given circuit diagram this is node 2. Node 2 is connected to the branches like R2, R3, R5. If node 2 is connected to the branches like R2, R3, R5 with respect to the reference node V3, to analyze the or to find the unknown voltage like V2, I am going to analyze the currents like I2, I3 and I5, how it is flowing in the node 2 and its associated branches. See here, I2 is the current which is flowing from node 2 to node 1, which is current away from the node, and I3 is the current which is flowing from node 2 to another voltage called VB, and I5 is the current which is flowing from node 2 to node 3, I mean with respect to reference node. So now I am going to apply the Kirchhoff's current law for node 2. If I apply the Kirchhoff's current law for node 2, means all currents are moving away from the node, like I2 plus I3 plus I5 is equal to 0. So if I2 plus I3 plus I5 is equal to 0 means I can write that equation with respect to Ohm's law. That is, I2 means I can write that V2 minus V1 divided by R2. Next, I3 means I can write that V2 minus VB divided by R3. I can write that I5, it is nothing but V2 minus V3. V3 already 0. So V2 minus 0 or V2 divided by R5 is equal to 0. By simplifying this equation, I mean that by making that separate like V1 and V2, the above equation follows as like this. That is, if you take here V1 as common, then it is minus V1 divided by R2, and if you take that V2 as common, here 1 by R2, here 1 by R3, here 1 by R5, that is equal minus VB by R3. If I am sending to the right hand side, then the above equation can become as minus V1 of 1 by R2 plus V2 of 1 by R2 plus 1 by R3 plus 1 by R5 is equal VB divided by R3. Now the above two equations are like equation number 1 and equation number 2. If we solve this equation number 1 and 2, and we are going to find out the two unknown node voltages like V1 and V2, either by direct inspection method or by Cramer's rule. Let us go through a problem, that is, use the node voltage method to find how much power the 2 ampere source extracts from the circuit shown in figure. Here there is a 2 amperes current source. How much power it is extracting, that we have to calculate. So to find out that unknown power across the 2 amperes current source, let us analyze that unknown node voltages. The unknown node voltage labeled as node A. Node A having that a voltage of VA with respect to the ground. So with respect to the ground, if it is VA, then I am going to write that analysis with the given circuit. So in this node A is connected to one current source. That means here we know the current source. So that value already we know, that is 2 amperes, where the current is moving from node A towards reference. And one more current which is flowing A to reference. And one more current is flowing A to reference. With these three currents, we can write that the current which is moving away from the node, we can write it as 2. And the current which is flowing in this direction, we can write it as VA by 4. And the current which is flowing from A to 55, we can write it as VA minus 55 by 5 is equal to 0. By solving this equation here, we get that VA is equal to 20 volts. Now VA is equal to 20 volts, that is nothing but the voltage across the current source, because current source is connected across these 4 ohms. So across these 4 ohms, that is the voltage of VA. Now VA is 20 volts. If I want to calculate the power across the 2 amperes current source, what is the power formula? The power formula, that is P is equal V into I, because already here we know the value of current I 2 amperes. Now the value of voltage is 20, therefore 22 is 40 watts. 40 watts is the amount of power which is absorbing by this 2 amperes current source. So this is the way how we can find out that unknown node voltage and later the remaining unknown parameters according to the given problem. Thank you.